as far as the frictional force is considered, normally we have rules to show the friction force. So the rule number 1, friction force always act in a direction opposite to motion. Normal reaction we have just seen, and the friction force is directly proportional to normal reaction. So I will use the symbol FF, is always proportional to N, normal reaction N. Now he says the friction force is independent of area in contact because the force is acting at one point, and because of that one, whatever the area in contact will not come in the picture. But if it is a stress, then area will come in picture. Force will acting at one point, that is the resultant force. And very complicated about the friction force is number 4. Now this rule number 4 makes the friction very difficult to understand. It's a self-adjusting. Likewise, tension, compression, normal reaction, they have fixed value. Their magnitude will not change. But as far as the friction is considered, the magnitude will change. And if you understand the friction, then you have to see what exactly the value is acting, and then you have to use that value. So let's consider here one block, a very huge size, and the weight of this one, will it act vertically downward? And exactly in the opposite direction, we will get a normal reaction. So this one is the weight W, and this one is the normal reaction. As far as friction is considered, you always use sigma Fy first and then sigma Fx. Your problem will solve very quickly. As far as sigma Fy is concerned, is this normal reaction is same as W. So we have a graph here along y-axis, friction force and applied force. Right now no force is applied. Is it correct? Is your starting point is here? No force, no external force applied. So you start from this point. As far as one person is considered, and suppose he is a healthy person, he can apply a force of 400 Newton, like my size. So if you apply the force of 400 Newton, and you can imagine this is a very concrete block, is a very heavy. So will the block will move or will not move? This 400 Newton will be here. Is it correct? And you will get a certain value of friction force. Let's say this is the value of friction force. This is corresponds to 1 person equal to 400 Newton. Since the block is not moving, so to help this, another person will come. He will apply the pull. Let's say another pull of 400 Newton, but the block is still stationary. So what you observe here, if you apply the one force, are you getting a friction force here? If you have 2 person, is the friction force automatically adjusted? This is what a self-adjusting force. The block is not still moving. So let's introduce one heavy person like this. Who can apply thousands of newtons. Is okay? So let the Khali come in the picture and he will apply the force here. Okay? But the block still is not moving. Remember this. So this force is here. What is the observation? Is the friction force is increasing. Now taking the advantage of this, a kid will come and push the block. As soon as the kid will apply the force, the block will start moving. Okay? Now what exactly? I observe this force is called the maximum value of friction force. We just call this as friction force. We just call this as friction force, F1. As per the definition is mu1 times n. As per definition is mu2 times n. And as per this definition, I will introduce mu s times n. What is this mu s? So this represents the static condition. That is, the block will remain stationary. But as soon as the kid will apply the force, the static condition has changed to dynamic condition. And as soon as the dynamic condition has changed, the force, the friction force has dropped suddenly. And now we have a friction force here which is given by mu k multiplied by n. And remember, mu k is called as coefficient of kinetic friction. And this value is always less than coefficient of static friction. Now what exactly happens here? From point A to point B, or let's say some point here C, very near to B, is the block is at rest, will not move, and is the value of coefficient of friction continuously vary as mu1, mu2, mu3, and when you reach at point B, this is basically called as impending motion. What is impending motion? Is just on the verge of motion, is neither stationary neither in motion. That is the maximum static condition. But any force exceeds than this, your body will come in motion. So as far as first part is considered, your equation is sigma fx equals to 0. Remember this, huh? Sigma fx is 0. And what is sigma fx? So if I say this force equals to F, as per the given rules, this is a friction force, and this force is mu times n. So you can, this force F, friction force is negative, mu n equal to 0. Correct? Equate this value, find out this force, whatever the external force you apply, put it here, normal reaction is fixed. Are you able to calculate different value of mu? Is it correct? So try to understand the theory. If you are between A to C, then this equation is valid. Exactly at point B, what is the condition? Is F minus mu s into n equal to 0. So this will define the static condition. But when you come here, the body is moving. This is called as dynamic condition. Now see here, 1%, second person, plus khali, plus kid. So the force has been increased. And this additional force make your equation to rewrite like this. Fx equal to m times ax. Because this difference of force is used to inertia to the body. And therefore the body will accelerate with acceleration equals to ax. Now the question is, where you are in the friction problem. Are you between A to C, or at B, or somewhere at here D? This is never given to you. And that is a tricky solution. And that is why the friction problem is very difficult to understand. If a block is given, if we have a block on an inclined plane, then the weight of this component will act vertically downward. So this weight you can resolve into two components. One is like this and other is like this. So if this angle is this angle is 90 minus theta. So what is this angle? Is it also 90 minus theta? And is this one is a 90? So is this angle is same as theta? Correct? This angle is theta. So is this angle is 90 minus theta? So opposite is 90 minus theta. This one is 90. So is this angle is theta? So this one is always equals to W cos theta. And this one is always W sin theta. Drawing a FBD is also skill. How you draw the FBD is also a skill in mechanics. So next time, if you come across this type of figure, you show one arrow like this and one arrow like this. And try to show the arrow inside the block only. Don't show any arrow outside the block. So this force will be W sin theta. And this force is W cos theta. Or you can remember this way, the force parallel to the plane is W sin theta and perpendicular to W cos theta. Then you show the normal reaction. This is the normal reaction N. Out of these two forces, W cos theta will try to cancel N, whereas W sin theta will try to move the body in a downward direction. Out of these two forces, W sin theta will try to make the body in a downward direction. So that is the only force responsible for the movement of the block. W cos theta will be cancelled with N. So because of this one, you identify the motion is this. This is my rule number 1. Is it correct? So very first thing in the friction problem, I identify motion. So this one is the direction of motion, correct? So this one is the direction of motion because of the W sin theta, and as soon as you observe the direction of motion, you immediately show the friction force at the point of contact, and you write this value equals to mu into N. So apply sigma Fy, that equals to N minus W cos theta. Apply sigma Fx mu N W sin theta, and then you can find out the value of coefficient of friction. From this we can define the angle of repose. Do you remember angle of repose? Self-locking concept. So suppose this angle is theta, and suppose phi is equal to tan inverse of mu, and suppose the theta is equal to phi, so body is in the what? Verge of motion. Is it correct? Neither sliding, neither in motion. But if this angle theta is less than phi, then what will happen? The body will start moving. So body will start in moving, so you are applying this equation. That is dynamic motion. Correct? Sorry. If the slope is like this, the body is always in static condition. So if the body is static, you can apply this equation and you can find out mu or mu s what you want. But if the plane is like this, the body will start moving, always in motion. So if the value of theta equals to phi, then you are representing the position B. Correct? As far as this figure is concerned, we are representing the position B. If value of theta is less than phi, then we are representing the position D. Or theta is less than phi, then are you representing the position A to C? कम, अगर एंगल कम है phi से, तो आपका बॉडी क्या रहेगा? स्टैटिक रहेगा. Agree or not agree? And if the angle is increased, theta is more than phi, then what will happen? The body will start in motion, and this represents the point D. This is how you can apply the friction equation. Here, let's say another concept. Let's say this one is a block of weight equal to, this is a block A, and let's say this is block B. And we want to find out this force, P, to move the block B rightward. Let's say this one is coefficient of friction mu1 and this one is coefficient of friction mu2. They are connected by one string. So as soon as string will come in picture, it is always in tension. In mechanics, you see the string or flexible is always in tension. Tension is internal force, and mechanics gives you full permission to cancel the internal force. Now imagine what will going to happen. Will the body B will move first or the body A will move first? You are applying the force directly to B. As per the figure shown, the force is applied on B. So will the body B will move first or body A will move first? Forget about this, that A will oppose B or B will oppose A. Forget about that one. Which body will get its first motion? B will get first motion. So start constructing FBD from that body. So do not consider rest body. Even there are 3 more bodies there. You start with that body where the external force is applied and which has the first chance to move. Now you start always from the external force applied, that is from B. Then you come to A. How are you going to start this? So first of all, let's show the force W1 or WB. Then show the normal reaction NB. Then show the weight of WA. So this body will push this body, so the weight will act downward, and will you get a normal reaction like this? Is body A and B are in contact, so there is a normal reaction NA. Body A will push the body B in a downward direction. At the same time, by Newton's third law, body B will pull or push the body A in a upward direction. Now finish this part. Do not think of friction right now. Is this exercise is finished? Now you can orally calculate this. Is NA is equals to WA? And is this NA plus this WB is equal to NB? So is this value is WA plus WB? Sigma Fi you can make oral. For the first figure, when you are applying the sigma Fi, in the case of friction, always start from the top figure. Now when you are thinking of friction, check the motion first. Motion is given to B. If the motion is given to B, the B has two contact surface. One in between A and B and one between B and ground. And this friction force will act opposite to motion. That is what rule number 1 says. Rule number 2 says that the friction force is proportional to the normal reaction. The normal reaction at the bottom is NB. And the normal reaction on the top surface is NA. So first job is done. Then come to the second figure. Whenever we have a contact, we have Newton's third law. So this one is an action, so this one is reaction. This one is mu1, and this one is n2. This is how you can finish up when the two body will come in contact and all contact surfaces has certain coefficient of friction. Okay, let's consider one block, and this is very heavy block. It has a normal reaction N, and the normal reaction N right now is W. And I am applying the certain force F. Now this force is not sufficient to overcome the friction force, which is mu s time N. So I don't have this value of force. That is, suppose this one is 100 Newton. So normal reaction is also 100 Newton. And suppose mu s is 0.2. So we have a 20 Newton force. So if I apply 10 Newton force, imagine that I applied only 10 Newton force. So is my friction force is 20, or is my friction force is mu times N? Now tell me, what is the maximum friction force? 20. Correct? The maximum friction force right now is 20. How much force I am applying? 10. Now if you visualize the figure, what is the maximum value of friction force? Is it 20 Newton on this graph, and is this value is this point? But how much force I am applying? Is it only 10 Newton? So is this 10 Newton is sufficient to overcome the friction force, or is not sufficient to overcome the friction force? So are you in the region A to C or A to C, something like this? Is it correct? You are inside here. Is this condition is a static condition? And if it is a static condition, is the value of mu is less than mu s? No question of mu k. because you are in static. But whatever the coefficient of friction is there, is that value is less than 0.2. And are you able to calculate this coefficient of friction? Because the external force is F and your body, on this axis I have written the external force. Is it correct? And this external force must equals to mu times N. So external force is 10, this one is mu, external force is 10, this is 100. So is the value of mu equal to 0.1? Correct. So you can find here the coefficient of friction is 0.1. Is this value is less than 0.2? If you apply the 15 Newton, then what will happen? This is 15 is mu multiplied by 100. So is mu equal to 0.15? Every time you apply the force, your coefficient of friction is automatically adjusted. You don't have to do anything. Now the question in my problem is this. I have a certain constraint. The constraint is 10 Newton. I have only a source of force available is 10 Newton. And I still want to move this body. So one option is that can we reduce the right hand side? Okay. Suppose I pull this body in this direction. So will it develop a tension? And if I apply this one, then is T is acting upward? Is W is acting downward? So because of this, is a normal reaction N is W minus T? Is that correct? So if normal reaction is W minus T, then will the friction force will change? Correct. Suppose tension equal to 5 Newton. So is this net value, normal reaction will be 95? Correct. If I increase the tension to 50 Newton, is this value will become 50 Newton? If I increase this tension to 70 Newton, that facility I am having. Lifting facility I have, but I don't have pulling facility. So if that is true, then is it 30 Newton? Correct. So what is the maximum value of friction force if we apply one rope on the top side? Is it equal to 0.2, that is mu static, multiplied by 30, and therefore is it equal to 6 Newton only? Whereas I have allowable force equal to what, 10. So can I successfully move the heavy body? This is what you have seen on the dockyard. This type of the movement will be done like this. This is a very heavy load. So they pull it by using the crane. Is it correct? And very small force is applied to move it translate. But if the same thing is done on the ground, do you require very heavy force? But if you attach one cable and pull it, don't pull it from the ground. That is, do not apply this force more than weight. Suppose you apply 110. The body will pull up. Is it correct? If body will pull up, the contact is lost. So there is no question of friction force. Agree? If it is 110, weight is 100, the body will pull up. Contact is there, or there is no contact. So friction force will not come in picture. This tension will be available and is less than 100. Then only you can apply this idea.